Hello everyone, this is Prashanth. In the last lecture, just we have completed about communication protocols, like that is interfaces with the IoT devices. So what are the communication protocols? Just UART and SPI and inter-integrated circuit communication protocols. The complete description of these three communication protocol, one is asynchronous, remaining two synchronous communication. Just basically the protocols are synchronous communication protocols and asynchronous communication protocol. In asynchronous communication protocol, just we have to maintain a clock signal. In asynchronous communication protocol, we have to maintain without a clock signal. Like that, just we have studying about some differentiations and some features, like everything just we discussed about the UART simple serial peripheral interface and inter-integrated communication protocol. So these are the things we discussed in the advantage, disadvantage, features, real-time use cases, installation consideration, environmental considerations, so like that. So many things we discussed in the last class regarding these three communication protocol. Now we move entering into the another module, that is introduction to IoT devices and endpoints. So this is the last module from according to the syllabus, IoT devices, introduction to IoT devices and endpoints. Let's discuss about the first introduction point here. In the part of introduction point, what is an IoT device? In the part of introduction to IoT device and endpoints, so the basic information, IoT devices we already know. What are the IoT device? What are the main specifications of IoT device? What are the functionalities of IoT devices? What are the requirements, considerations, environmental considerations, outside considerations, inside considerations? So many things we studied regarding the IoT devices. So along with that, endpoints, what are the applications we are going to develop based on our requirement, that is the endpoints here. Before that, what is an IoT device? What is an IoT endpoint? Differences between these two, and examples of IoT device and endpoints. These are the things I am going to explain right now. IoT device, physical objects with sensors, actuators, connectivity to collect, transmit data, that is the IoT device. So simply, for example, in your room there is a fan. This fan, just it can connect to the so this is the first ideal mode. Just when you connect it to the internet, just it can be transformed into the IoT device. That is okay. So after that, just we can before connecting, just we can authenticate the device, or we can authenticate all details like that based on the sensor data, sensors, actuators, connected to collect, transmit data. And IoT endpoints. So the digital representation of IoT devices is in a network where data is processed and managed. So the endpoints is nothing but here the digital representation of IoT devices. Just you can digital representation is nothing but, so this is a pen. The pen, just this is the normal pen. This is okay. When you connect one new LCD display to this pen, so how much ink it is having, how much ink it is going to expire in how many days, how much what is the weight of this pen, like that some information will display on this LCD display. That is the digital representation of a IoT device. So IoT device in a network where data is processed and managed. So in this LCD display, just we can see the information of digitally regarding this pen. So this is the IoT endpoints and IoT devices. So this is the some introduction points of IoT device and endpoints. Next one, IoT device versus endpoints, a clear distinction here. Physical device. The physical device is not IoT. Physical is nothing but physical entity, data generation, limited processing, and some examples here. Physical. What is physical entity here? A tangible object equipped with sensors, actuators and connectivity here, equipped with sensors, actuators and connectivity. Next, data generation collects the data from the physical world through sensors, and limited processing often has a basic processing capabilities for initial data analysis, like that. The example, say a smart thermostat, wearables, and industrial sensors. So these are the some discuss about the IoT device and endpoints. Next one, digital representation, IoT device versus endpoint. Some more bits here. Digital representation of this device, just we already discussed in the just now only. Data processing in term by using how the data will be collected, how the data will be transmitted, like that. And communication, some example here, cloud servers, mobile applications and gateways. So just communication developed based on the different communication protocols like Bluetooth, Zigbee, Wi-Fi, whatever communication available, just depends on the requirement. Just we may use to process the data. And in essence of essential thing here, an IoT device is the thing in the physical world that interacts with its environment. An endpoint is the digital twin of the device responsible for data management and interaction with the other systems. Analogy, the similarity, think is an IoT device has a human body with an endpoint as the brain that process sensor information, make decision and control actions. So this is the essence and analogy among the IoT devices. Next one, examples of IoT device and endpoints here. Here smartphone, wearables and industrial IoT. In smart homes, just we have thermostats, smart lights, door locks and security cameras. In wearable, smart watches, fitness trackers, health monitoring system, patient monitoring system, soil mature system, forest detection system, like that. We have so many IoT applications are available in market. Industrial IoT, in terms of industrial IoT, we have temperature sensor, pressure sensor, vibration sensor and motor controller. So these are the some IoT devices. Depends on the modes, smart home mode, wearable mode, industrial mode. So these are the endpoints. So in order to develop the platforms like Amazon cloud platforms, mobile applications, IoT gateways and data analytic platforms. In terms of platforms, Amazon Web Services, Microsoft Azure, Google Cloud platform under cloud platforms. And mobile applications here, smartphone app for controlling IoT device, wearable device companion applications here, and IoT gateways. So here devices that bridge the gate gap between IoT device and networks. The data analytics platform, sensor for processing and analyzing of IoT data. So these are the examples for some IoT endpoints gateways like platforms. In terms of cloud platform, mobile application, IoT gateways and data analytics platforms. Next one, device endpoint relationship examples here. Start with smart thermostat, wearable fitness tracker, industrial sensor network. So here, smart thermostat itself, if the device is the mobile app or cloud-based control plan is the endpoint here. Wearable fitness tracker, the tracker is the device and the smartphone application that displays data and provides insight of the endpoint. Industrial sensor, the sensor is the device and the cloud-based platform that collects and analyzes sensor data is the endpoint. So these are the three endpoint device endpoint relationship example: smart thermostat, wearable fitness tracker, industrial sensor. Next one, importance of installation and interfaces devices, IoT devices here. The role of installation in IoT devices life cycle. Very important term, IoT device life cycle. IoT device IoT device life cycle is very, very important. Importance of efficient communication between devices and endpoints, like one more, and overview of different types of interfaces like that. And installation process, interfaces, the process of IoT, setting up IoT device in their intended environment, and interfaces, the methods used for communication between IoT device and other systems. So installation and interfaces are very, very important terms to setting up the environment. Next, the role of installation in the IoT life cycle. So here the installation is a critical phase in the IoT device life cycle. So very, very important. IoT, in order to study about the IoT device life cycle, just we have to know these are the minimum things that bridges the gap between the manufacturing and operational stages. It's where the theoretical becomes the practical, and that devices transmission from the product to a functional component of larger system. The key role of installation here: physical deployment and configuration and setup. In terms of physical deployment, just we have placed the correct placement of the device in its intended environment like that, and ensuring optional sensors to placement for accurate data selection. So in order to get the accurate data collection, just we have to ensure the optimal sensor placement is correctly, and to prevent the damage, just proper mounting and secure, we have to maintain proper mounting and securing. That is the thing. Next, in terms of configuration and setup, the initialization, device setting of the parameters and connecting the device to the appropriate network, that is Wi-Fi or cellular like that, and configuration, communication protocols and data transmission settings like that. So these are the key roles of installation in terms of physical documentation, physical deployment and configuration and setup. Next, continue with the next slide. Integration with the systems, overall user onboarding service, and security implementation and testing and validation. Finally, just we can test the device and validation, whether it is valid for how many days, whether it is valid for some minimum number of days or maximum number of days like that. The integration with systems here, connecting the devices to other IoT components or system like that, to develop the background infrastructure, ensuring seamless of data flow, integrating the device into existing IoT systems or platforms. So these are the three things under integration with systems. And in onboarding, it support for device operation, providing necessary instructions, that is the minimum things, and device efficiently, in enabling users to interact with the device efficiently, and ensuring user satisfaction and understanding of device functionality. That is the onboarding, user onboarding service. And security implementation, it is also one of the important factor to maintain the overall network. So configuration, device security settings, and implementation, access controls and authentication mechanism, protecting the device and its data from unauthorized access. Testing and validation here, verifying the device functionality and performance after installation, and data collection and transmission to get, ensuring that valid data, and installation other related, like identifying and resolving the issues. Is there any issues may be occur in the middle of the network, that can be validated by the network. So these are the some key roles of installation of the device. Next one, importance of effective installation. So before installation is okay, to get the effective installation, to further we have optimized device performance. Proper installation ensures that device operates as intended, that is okay. Next one, enhances data quality. Yes, accurate sensor placement and configuration lead to reliable data, that is okay. Next, reduces troubleshooting efforts. A well installed device minimizes operational issues and improves the user experiences. Easy setup and intuitive operation enhance user satisfaction. Strengthens security posture also. Proper configuration and secure measures protect the device and data. So these are the effective installation, to get the effective installation of the device, optimize device performance, and enhances data quality and troubleshooting efforts, and improve user experience, like feedback from the stakeholders, and security posts. So these are the effective installation points. Next one, importance of effective communication between the device and endpoint. So here the main agenda is just IoT devices and endpoints. IoT device is nothing but physical devices. Endpoint is nothing but some platform by using IoT devices. So that is the thing. So here effective communication between IoT device and endpoints is the backbone of successful IoT implementation. That is very important term. It underpins the entire systems functionality and performance, hereby real-time data transfer. The first one, in terms of real-time data transfer, time-sensitive applications. In many IoT scenarios, data needs to be processed and acted upon immediately. Effective communication ensures minimal latency, enabling real-time decision making. That is okay. Next, to predictive maintenance. Here, by rapidly analyzing sensor data, potential data, equipment failure can be predicted, preventing costly downtime. So that is the under real-time data transfer, time-sensitive applications and predictive maintenance. Next one, scalability and reliability. So here in under scalability, growing network and flexible deployment. Reliability, continuous operation and data integrity is very most essential for integration of devices. Growing network. What is growing network? It is IoT device network increases. The communication infrastructure must be able to handle the increased data volume. Efficient communication protocols, network architecture are essential. In terms of flexibility deployment, the ability to scale communication capabilities up and down as needed, allow for ability to changing the requirements. That is the scalability. And reliability, continuous operation. IoT systems often operate in critical environments where downtime is unacceptable. Reliable communication ensures uninterrupted data flow. And data integrity, it efficient protocols and user error correction mechanism to protect data from corruption during the transmission. So these are the some endpoint effective communication between the endpoints and devices to improve the real-time data transfer, scalability and reliability. And energy efficiency and cost effectiveness, also these 2 points. Under energy efficient, we have 4 points: battery powered devices, extended battery life. In terms of security, data protection and privacy. So under every category, 2 points. Under energy efficiency, battery powered devices, many IoT devices operate on limited battery power. Efficient communication protocols helps conserve energy by minimizing data transmission overhead. Extended, just you can extend the battery life also based on the device. It reduces the maintenance of cost and environmental impacts. In terms of security, it can provide data protection. Secure communication channels protect sensitive data from the unauthorized access. And privacy, to maintain privacy, encryption and authentication of mechanism safeguard user privacy. It is essential things. And in terms of cost effective, optimize resource utilization, that is in terms of to reduces the network congestion, hardware requirements leading to lower cost. Improved system performance, that is faster data rate, reduced latency can enhance overall system efficiency. So that is the under cost effectiveness. Next, energy efficiency. These are the some similar effective communication. Next, overview of different types of interfaces. Here, interfaces can be several types based on their function. interaction by using their function, interaction method and technology involved. First function, based on the function, interaction method and technology involved. So here broad just elaboration of the different types of interfaces here under user interfaces. So here under user interfaces, graphical user interface, command line interface, menu driver interface, natural language interface, and touch screen interface. So these are the 5 user interfaces among the devices. Graphical user interface uses visual elements like icons, menus, and windows for interaction. This is the desktop operating system like mobile apps. Next, command line interface, CLI, GUI to CLI, text based interaction using commands like Linux terminal and command prompt. Like next, menu driver interaction, MDI. It presents option in menus for user selection, that is ATMs, vending machines, IOT devices, machine to machine devices, like that. Natural language interface, that is NLI, enables interaction through natural language process, that is voice assistants and chatbots. The last one, touchscreen interfaces, allows direct interaction with a display using touch screen, smartphones and tablets. So these are the 5 types of user interfaces: graphical user interface, CLI, command line interfaces, menu driver interface, natural language interface, and touch screen interface. Next to hardware interfaces. What are the hardware interfaces? Just we can connecting the one-to-one, back-to-back connection or front-to-front connection of any IoT devices. So that is serial interface, parallel interface, network interfaces, and sensor interface. So in a serial interface, just we transmit data sequentially 1 bit at a time. So that is serial. Just we already know in the last class only, UART, SPI, these 3 are very important serial communication to develop the IoT world. Parallel interface, transmit multiple bits simultaneously, USB or fireware examples. Network interface, connect devices to a network, Ethernet, Wi-Fi, Bluetooth, Zigbee, RFID, whatever, just to protocols, communication protocols available in the network. And sensor interface, connect sensor to a system, analog to digital converter, digital to analog converter, DAC or ADC. These 2 are under sensor. These are the hardware interfaces in order to connect to the IoT devices. And the software interfaces, API, very important one. Application programming interface, it defines how software components can interact. For example, API, application programming interface, just it can this is one company, company C1 and company C2. For example, the modules, the C2 are having some features, C1 also some having features. So the C1 company wants to use some features of C2. For that, compulsory the C1 get API code from the C2. That API code can interface with C1 API code. Then only the same features can used by the C1. So this is the main importance of application programming interface, that is API. It defines software components in interact, how the C1 and C2 can interact with the help of API code, like that only. So if you want to use the features of company 2 C2, compulsory that can API code can get by the just it can mutual interaction between the C1 and C2. Next to graphical user interface toolkit, it provides the building blocks for creating GUI. And command line interface, that is CLI library, other functions for interacting with the command line. Next one, database interface, allows interaction with the database, that is software These are the four software interfaces: application programming interface, graphical user interface, toolkit, command line interface tool library, and database interface. So these are the four software interfaces is very essential part. And other types: brain computer interface BCI, it connects to brain to a system, nothing but CPU. Human machine interface, that is HMI, facilitate interaction between human and machines. Human and machine. So human to human, human to machine, machine to human, machine to machine, like that we have different interactions. Next, serial communication, just examples. So here serial communication UART, serial communication SPI, serial communication I2C. The basic concept of serial communication, that is the protocol, structured flow control, advantage, disadvantages. Serial SPA, serial programming interface, SPA stands for. It is for master slave architecture, clocking, data rate, advantage, some disadvantages are UART. Use case of IoT. These are the some topics we are discussed in the last class to develop the IoT. Well, SPA communication is a synchronous serial communication protocol for short distance communication, often used for high speed data transfer. We know. Same I2C also, inter-integrated circuit. IEC, I2C nothing but IAC, inter-integrated circuit. Inter-integrated circuit protocol, it maintains multi-master architecture, addressing and data transfer. Advantage, disadvantage over the SPI essential things. It maintains multi-master serial communication for bus for connecting low-speed devices, high-speed devices for SPI. UART is the minimum. So these are the communication protocols, and comparison of interfaces here. So to table summarizing key characteristics of UART, SPI, I2C, we know. Comparison of interfaces. Some installation conditions are consideration also we have to discuss about here. Device mounting and placement, power supply options, how many power supplies options are available, and environmental factors like temperature, humidity, whatever the environmental factors, just we have to gather the data. And security and privacy consideration. Some also just we can provide some security protocols. We maintain some privacy considerations also. Installation consideration. In terms of installation consideration, device mounting placement, power supply options, environmental factors like temperature, humidity, exits, and the last one, security and privacy consideration. Installation consideration supports it factors to consider when placing and powering of IoT devices, including environmental conditions and security. So these are the some references I referred for this lecture. Some ACI Scopus papers also I refer for this lecture, but I mentioned here only links, whichever the data from gathered from the online links. So these are the references. This is the lecture about IoT device and endpoints. IoT device is nothing but some physical devices we have to maintain to gather some data wherever we require. So the gathered data, just we move into the some online platforms that are the IoT endpoints. So this is the main things regarding IoT device and endpoints. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.